and welcome to H2O Stream. My name is Sion and I'm the editor at H2O Global News. I'm joined today by Marco Westergren. He's the Chief Analytics Officer at InfoTiles. Marco, thanks for joining me.
Yeah, so my name is Marco Westergren. I'm an amateur water user for 36 years and a professional for the last 13. My background is initially in natural hydrology, but I've spent most of my work experience working in the intersection between natural and man-made water structures, with a particular emphasis on data analysis and insights.
Great. And what exactly do you do at InfoTiles? Can you tell me a little bit more about the company?
Yeah, so the company was founded in 2016. I joined in 2019, and we've built an event streaming platform, which is built to be highly capable at processing large amounts of different data types in a cost-efficient manner. And from my background and experience, I had experienced quite a few of the typical pain points that occur when working within water, both from a natural management and operating complex networks. And we found a synergy between their technology and my needs, which led us to focus purely on applications within the water sector. As the Chief Analytics Officer, I manage the data science team, and we do both research as well as production of solutions that we feel are of value for utility owners.
Thanks, Marco. And so, working in the digital water space, what are some of the key challenges in the water industry with regards to digital transformation?
Well, one of the major challenges is, in order to do data analytics, you have to have data to analyze. And as the sector as a whole is roughly divided between early digital adopters and late digital adopters, which means one crowd has a lot of what we would call legacy. Basically, the initial documentation, it was built in the 1800s, basically before digital was an option, didn't contain the amount of information we would want to have registered today. And the other party is, the biggest issue is lack of information. We have water theft. We have very few measurement points. We don't know what the infrastructure looks like. So putting it all together and provide insights provides very interesting challenges, both for the people who want to optimize, but also for starting from scratch.
And just to kind of zoom out a little bit, what does digital transformation in the water sector, what does that look like? What are some of the key innovations and approaches that we're talking about?
In my highly biased opinion, a lot of the value is to tackle the problems that are usually tackled manually today, which is they have a GIS-based system of their infrastructure. There's public data sets of weather data, river and stream flow, and also weather forecasts, of course. There's the asset management, if you will, the nuts and bolts, and there's the recent developments in IoT. But instead of coming together, they typically live side by side, and the potential value that can be extracted with technology that we have today is not being realized.
Thanks, Marco. So with that kind of idea and within that context, what are some of the specific water-related challenges that InfoTiles target with their approach?
We have different solutions. I wanted to focus on one because it explains how they're connected, which is detection, quantification, and risk that's caused by inflow and infiltration on the wastewater network. There are several competing solutions in the market. Some are IoT based with new sensors to gather information that they didn't have before. But our focus has been on how can we tailor a product that will be available to everyone. So we focused on the level measurements from wastewater pumping stations. We didn't require flow. We didn't require technical information because we don't always have that. But in order for a pump to activate and deactivate, the system requires a level measurement, so it will be omnipresent. From this, we've worked with our machine learning team and utilized precipitation data and the level data to be able to distinguish what's the total volume and how much of it is excessive. And the next step is, of course, when you find the distribution over your large network, it's not always homogeneous. There are typically a few that are a bigger cause of the problem. And by having the information of which candidates have the most improvement potential due to repairs, the next step is how do we repair it? And we also have the network information. So we know exactly which pipes can lead water to this measurement. So we can use machine learning again to say which elements have the highest risk of causing inflow and infiltration, allowing them to travel to the site and confirm it by video inspection, or even directly order simplified renovation methods such as lining, which does not have the same lifespan as a complete replacement, but will give you a short-term benefit, and you can measure that the repair has had the intended results.
That's really interesting. It's great how you're bringing everything together there. So can you give an example of an application of this technology in a real-world scenario?
Yeah, we actually have multiple deployments in production today. As a natural scientist at heart, it was very important to me that this was not client-specific or region-specific. So we have deployments in flat areas where groundwater and infiltration, as well as rivers, is a cause. We have deployments in coastal areas, which are prone to seawater intrusion. And we have deployments in mountainous areas, and are happy and relieved to confirm that it does function for all applications. And we have clients running this today all the way from Norway to Switzerland, and are looking for deployments in other countries and regions in the near future.
Fantastic. And I mean, considering you're applying this technology across many different regions and in many different cases, what are some of the key benefits that you've seen coming out of all of these different examples?
Sustainability is high on the agenda everywhere these days. So being able to take the step from an anomaly detection or numbers that will only make sense to highly technical personnel, we provide hard figures. What does this mean in CO2 footprint? What does this mean for energy consumption? And what does this mean in direct treatment costs where those numbers are available. So we managed to attach hard figures to an issue that is almost unknown outside of a utility or the technical department within a city or municipality, and talk to them and provide proof in a way that is easily understandable, because that means there's a shorter way to action and repairs and reduction. And with the power situation in Europe over the last year and current situation, this has moved higher on the agenda. And the potential is massive, on the magnitude of millions of kilowatt hours per year.
Yeah, that's actually really exciting. And it's interesting to see how, water and energy, we know there's a nexus between them, and how these solutions can actually make impact beyond just the water sector, but help us tackle other challenges, like you mentioned, the energy crisis in Europe at the moment. And just to go beyond Europe, do you think these technologies are transferable to other parts of the world?
Absolutely. The beautiful thing about water is it's always relevant, but the nature is highly variable, whether it's having too much, having too little, having too poor quality. It has a direct effect on people's lives. And for our home area in Norway has gone under the radar because we haven't experienced water stress in the past 50 years. There has been flooding events, but droughts are becoming an issue here. And the combination of monitoring devices, assets, and insights can be applied for leakage detection. If you have limited water supply, losing it is a bigger problem than inflow and infiltration, but it requires the exact same building blocks with a switch of focus.
Yeah, definitely. I think like what you said about having that data and having a way to analyze it and make informed decisions from that is applicable no matter where you are in the world. I think that's really helpful for water managers. And earlier you mentioned that sustainability is really, it's on the top of everybody's agenda across the world. And we're talking about digital transformation in water. Do you think that the water industry has a choice when it comes to adopting digital technologies if they are to achieve sustainability?
I think it would be very difficult to avoid it, because the amount of information in order to act optimally, make the right decisions, is too much to be done manually. And if it's done after the fact, it could be too late, or the situation has changed in the meantime. So when we have the technology to utilize the computing power and reduce the complexity into more palatable insights in chunks, it has trailing effects, not only for focusing on a single use case at a time, but in the larger perspective, how should we manage tomorrow, next week, over the 5 years to come? And can we anticipate what would be problems in the future?
Yeah, that makes a lot of sense. And I think as the world is changing and things are becoming less predictable and water's becoming more scarce, or there's flooding events, whether it's less of it, more of it, or changes in quality, the fact is that digital technologies and the awareness it brings I mean, I don't think many people can debate that that's an essential step towards achieving the goals that we need to achieve. So just in that line, and a final question, what does the future hold, do you think, for the water sector in this context of the digital transformation? Maybe what are some of the things you'd like to see?
As I touched upon in the beginning, with coming from an analysis perspective, you need to have data to analyze to begin with, which narrows it down to applications where you have a set starting point. But the developments that have been made over the past 30 years in remote sensing, both in terms of very high resolution mapping that could be done by airplane or helicopter, but even satellite products, are approaching a resolution where it has direct unique applications within water. And the beauty of satellite is you're not limited to certain areas or political stability. You have global coverage. And I think we will see satellite products being made available targeting water-related problems, both in terms of glacial development from altimeters, from soil saturation and availability using synthetic aperture radar, and the development in tools and data sharing that makes it available for day-to-day use and not only for research purposes for people with a highly specialized skill set.
Yeah, thanks, Marco. It's great to talk and to kind of get a broad overview of the digital transformation in water, but also specifically what you're doing at InfoTiles and how that relates to challenges that you're facing in Norway, but also how that's applicable throughout the world. So I think this is just the beginning of the conversation, and there's a lot of exciting things to come. And I think we definitely have to get you back on to talk again about some of the other developments that you're doing at the company and some more trends that you see. But for now, I'd just like to thank you for joining me. It's been great to talk, and I hope all our viewers out there have found this really informative. I know I have. So just on that note, I'd like to wrap up and just thank you very much for your time. For all of the viewers out there, we're going to put Marco's details and the details for InfoTiles at the end of the video. So if you'd like to reach out or find out a bit more about the company or the work that Marco's doing, feel free to contact them there. But otherwise, have a great day further.
Thank you so much for having me, and it's been a pleasure. I always like to talk water.
Yep, that's what we're all about.